Good afternoon, everyone. So for the next 20 minutes or so, we'll look at a new architectural approach called the cell-based architecture that allows teams to make rapid changes to this distributed set of microservices safely and efficiently. So today we'll look at what's the problem with the traditional architectures, like monolithic architectures, what's the big problem, and then we'll introduce cell-based architecture. And then we'll go through some of the core principles of cell-based architecture, what it's kind of built on. And then we'll kind of zoom into an anatomy of a cell, and then discuss about how to design systems and microservices with cells. And then we look at some benefits and then some gotchas at the end. So to define the problem with monolithic architecture, so we've either worked with or working with some of the monolithic programs right now. So you've seen, if you've seen the evolution, most of these systems starts very simple, and then as the time grows on, they get accumulated with features and then ended up with this tangle of kind of web of dependencies. And the issue with that is to make even a small change, you need to understand and then master the entire system scope. And then you need to have detailed tests to make sure your change is applied safely. So it becomes even kind of a very minor bug can bring the entire system down, which is a big problem. And then it's difficult to scale because you need to scale the entire application as a whole. And then for new hires, of course, people can't be productive in a very short amount of time because they need to master the entire program in order to make these changes safely, which is a kind of become a struggle for teams to deliver fast. So this new architecture is basically based on three key ideas. So first, decentralization. So rather than having a central kind of a model, you distribute control and data, and then they basically is loosely coupled components. So having loosely coupled components is important because you can make changes to a system without breaking other parts of the system. And it's rather than being able to scale the entire system, we need to scale independent portions of the system based on their data use cases and then the usage patterns. So coming to cell-based architecture, so it's an approach that structure an entire organization or an entire system with distributed and also independent self-contained units called cells. We'll look at what cells looks like and what's the kind of how it's built on, how it communicated on. So cell-based architecture is kind of co-authored by our current CTO, Asanka, and then our former CTO, Paul Fremantle. So it's not just a theoretical foundation to build services. There are some success cases outside of WSO2 as well. So there are some big companies who's using cell-based architecture to structure their internal services and internal APIs that they organize and that they deliver. So you probably heard some of these names. So Okta is a kind of an identity management company, also a competitor for our identity solution. So DoorDash, I think it's not big in Sri Lanka, but it's very big in US. It's like a Uber Eats pick me for food delivery. And then Booking.com, I'm pretty sure everyone here has heard of Booking.com. So you can book hotels and other vacation rentals through Booking.com. So if you look at I'm not expecting you to read the kind of the small text here. So this is actual system of microservices model using cell-based architecture. So the octagonal shape that you see here is what we call a cell. Inside a cell, we have a number of microservices. So it's not just a microservice that is inside a cell. So if you look at a purpose of a cell, it's like a vertical slice of a business unit or a business function that is encapsulated in a self-contained unit. And when one cell wants to talk to another cell, it always talks through a well-defined interface or an API. So there are core principles that's sort of built on cell-based architecture. First of all, this decentralization. So there are no centralized management units. So each and every component or each and every cell is basically scaled independently, and then used to based on. Also, it's also important to note that when you are designing the system from like when you're whiteboarding and when you are figuring out what are the cells that you need, you basically what we do is basically we whiteboard and figure out what these components, right? And then we model the architecture, and also at the deployment time, the architecture becomes a deployable unit. So the cell-based architecture gives a consistent framework that can go from a whiteboard to the runtime. And of course, loosely coupled communication. So it communicates to secure channels through a managed gateway. So all the incoming and outgoing data in a cell is handled through a well-defined interface. And it's independently deployable in the sense that it's owned and managed by an independent team, and then you can do changes to a cell without having to do big bang rewrites to other parts of a system. So which becomes a big advantage when you want to push updates to a cell or update to a certain components inside a cell without having to break other parts of the system. And then you need high observability. What we mean by high observability is that inside a cell you need to manage how you log, how the logs are aggregated, or how the logs are done for all the microservices, and of course how it can be monitoring and tracing is also should happen inside a cell. And of course what we say is that a team or a small team can own one cell or one or many cells, and then they have the full autonomy and full control when they're designing and then deploying these cells. So now if we zoom into what goes inside a cell, so first of all, the outside of the boundary of the octagon, at the top you can see there's a kind of a, I don't think you can read the text here. So that is the primarily what we call is API or a cell gateway or a proxy, essentially. So this becomes the front door into the cell. So what this means in practice is that all your routing logic, all your security policies, and things like rate limiting and other governance policies are done using the cell. And also it can be, so in this diagram it shows as one kind of gateway, and then in practice there can be one or two gateways based on whether if you want to separate out ingress traffic and also egress traffic. So whatever traffic that comes into a cell and goes outside a cell is managed through a gateway. And if the components, inside the cell, we call it as components. So inside the cell, it can be multiple microservices, or we can wrap legacy systems inside a cell and then deploy that as well. So in practice, we've seen customers wrapping like databases and other kind of smallish things that you can deploy into a Kubernetes inside the cell and then deploy that as a unit. Usually things like big systems that are very hard to move, like if you have systems like SAP and other systems of records, usually we don't see those getting wrapped inside a cell and deployed, but those are, what we see in practice is that you define like a outbound connection and use the outbound connection within the cells to talk to external systems. So those kind of things kind of live outside the cell-based architecture until that they can be moved to a cell. And also another important point is that each and every cell has its own private data stores. So it can be one or multiple databases. So the importance of that is whenever another cell wants to talk to a data point inside another cell, it doesn't directly talk to the database. It always has to go through a well-defined interface. That's an API that is exposed from a cell gateway, and that's how you usually expose a system of records. And then, of course, governance policies, security rate limiting is contained within the cell, So as a team, you can manage what are the policies that applies to a cell. So now, how do you design your system or design your microservices with cells? So first point to note here is that you need to identify what are your business domains. So one technique you can use here is domain-driven design, or DDD, to identify what are the kind of the business boundaries or team boundaries that's inside your organization, and then use the team boundaries as cells. So again, it's not a hard and fast rule to use teams or departments or like organizational units or business units as cells. Depending on how you want to go about it, you can define the granularity of cells. The screenshot here is from the WSO2's production organization that follows cell-based architecture, how we've grouped into cells. So there are certain team-wise groups that you can see here, like for example, finance and marketing. And there are some cells like the POC components that doesn't belong to a cell, but managed by like a dedicated team. So that can be a cell as well. And of course, when you are designing this, when you are breaking down cells or identifying cells, it's not kind of a science, but it's kind of an art that you have to figure out and iterate over and over. And then I think even in WSO2, the components and the cells that we have right now has been iterated over like 2.5 to 3 years or so. We had to refactor certain cells into like break down one cell into other cells, and then at certain times like group things to get together. And then once you identify your cells, then you have to identify your domains. You have to map the domains into cell boundaries. And then this is where you define, okay, what's kind of the best practice, what is best for you based on the interaction patterns with this, with the cells. And then once you identify that, you need to define what is my kind of the API contract that I am exposing to outside cells. It can be, here it says just a gateway contract. It's not like a global API contract that is living in the cell gateway, but it can be a combination of microservices that is exposing a well-defined interface through the cell gateway. And of course, you need to establish a communication pattern between cells when one cell needs to talk to another cell. Here, there are several interaction patterns that we can use. So this is kind of that's defined in this reference architecture, how one cell should communicate to other cells. So first is basically this synchronous request response. That's your standard HTTP API calls. You can have well-defined APIs that expose services and then use services from other cells. And the second one is event-based. So this is more like asynchronous event-based. So whenever a cell needs to know something or cell needs to do certain tasks, it can either publish an event to an event queue or read an event that is received from this event queue. And of course, the third defined interface is through streams, can be like WebSockets and things like that. So there are some benefits, of course, to this having cells. So one thing is this accelerates development, so teams can deploy changes independently of other systems. And of course, the failure paths are now isolated within a cell. So not like a monolithic program where you get a bug and the entire system goes down. Now the failure part is either constrained to a cell or either part of a certain very small substrate. And then you can scale these cells independently. Of course, so that's kind of the best practice that's defined in cells. So we'll look at how this is practically implemented in next. And of course, teams own these cells, and then they are responsible of delivering and then managing this cell on their own. So there are some considerations as well. So it's not just all good. There has to be something like complex and some bad things as well, right? So one of the immediate problems is that now you've gone from monolithic system to a completely distributed system, and then it's basically you can't just put a debug point and then debug these services, right? So you have to have very good observability tools built in to get logs and aggregate logs, and then give you a holistic view of what's going on in your services. And then when you are talking to services and APIs that lives on other cells, and if these API calls tend to be kind of transactional based, then you need to think about, when you are defining microservices, you need to think about like compensation transaction. If something fails in another cell, then you need to have a compensation transactions defined when you identify these cells to kind of roll back that change. And of course, it's an organizational shift as well. You are not just adapting a framework. You need to kind of refactor your teams to work with cells and then move in as different teams based on the framework. So implementing cell-based architecture, so this is a kind of a reference architecture that we have. And of course, here in the octagonal diagram is represented by a cell. So this is a implementation right now that we have in our Choreo product on the data plane side, how Choreo implements cell-based architecture. So here, of course, in the spec, it defines one gateway as a single point to receive and also a single point to kind of control outgoing traffic, right? So practically, we've implemented as two different gateways. So in the top section of the octagonal, you see an API gateway, so to handle all the ingress traffic. And at the bottom of the kind of the cell, you see an egress gateway that handles egress traffic. And of course, you have things like log collection, pushing all container logs to a centralized location. And then we are using Hubble to collect, Hubble is basically a framework built into Cilium to basically identify all this observability on the logs, what's happening, what's the interaction between services, and so on. So the important thing again is that when you have lots of microservices, usually all the monitoring stuff you need to install like an agent with all the microservices. So with Hubble and Cilium especially, it's an agentless monitoring framework, so the monitoring kind of becomes easy. But the other point is that when you have to manage and then manage this entire complex system, it's not an easy task to manage by a team. So you need to be experts on multiple technologies in order to manage this entire architecture. So if you want to implement and adapt cell-based architecture, there are like several approaches. First thing is you can do it yourself. So based on this reference architecture or reference implementation, you can pick and choose the components you want. You can swap out if you want to have a different gateway. You can use a different gateway. If you want to use certain different monitoring solution, you can use a monitoring solution. But ultimately, at the end of the day, you are going to end up with a similar architecture that models this one. So it's not going to be simpler. Or the second option is you can use Choreo, which is a SaaS product. So you just sign up and then start using Choreo through a web browser. And then it gives you the cell-based architecture without having to install anything. So you can start being productive from day one. Another option is that we have another product called Open Choreo, which is a completely free and open source version of this. Very similar to this, a complete runtime that implements cell-based architecture. And I think there were a couple of sessions on Open Choreo as well. So again, you have to set this up in your infrastructure, or you can set it up on your cloud provider and then start using cell-based architecture. And of course, there are several interfaces as well. There's a kind of a CLI interface that you can, and also a RESTful API when you're pushing artifacts or pushing microservices and then deploying into a kind of a cell. So key takeaways, so it's a very powerful model for building agile and scalable and resilient systems. And it's also based on this complete decentralization and also kind of loose coupling. And then teams can own and then manage, monitor, and then govern cells on their own. A cell, this is the most important part. So a cell is a self-contained and independently deployable unit that has its own kind of gateway, interfaces, and then logic and data. So adapting cell-based architecture, again, it's not just about adapting a technology kind of product. There has to be teams that are, you have to kind of embrace as an organization and then kind of buy into this cell-based architecture and then get the teams kind of rallying up and then to be able to be productive. That's what we've seen. Most organizations who has become more productive, they've organized their teams in a way that they manage certain domains on their own and then deliver on that.